Hello, in this video I would like to show you the second application in the Speakerbench suite, and that would be the fitter. And the first thing we do is we open up a browser, and in this case it'll be Chrome. And here we have the home page for Speakerbench, and we choose the fit data. And from the previous sessions, we already generated a data object, and as we can see here, it's very easy. There's just one thing you need to do, and that is drop this object here. So we will do that. And it'll take a few seconds here for Speakerbench to fit the data. And it's done. And in this case, the fit quality is excellent. And you can see in the manual that there are also other options. And actually, if you go up and click on the manual, you'll get a context related help. We will do that, and you can see it drops straight to the fitting procedure here, which shows what was fitted. And yep. And at the bottom here it says that the fit analyzes your data and the fit result, and it provides you with a quality rating, either excellent, good, fair, or sorry. And as you become more skilled in doing good, high quality added mass measurements, the rating should go up. And for us programmers, there's like a number of different error ratings here, which tells us a little bit about how bad is it in the mechanical domain or the electrical domain and so on. And after the fit is done, we get this new file, this JSON container, which contains your result. It's an ADV file for advanced model parameters, and it has a date and time stamp to it. So we will just save this file and put it here in my test folder, and here we go. The file is saved to your local hard drive, and we can go inside and see what's inside. And typically JSON, it's this format, single line, but it's not very big. You know, if you compare to when we did the impedances, you can see this is 29 kilobytes of data, and this is just 1 kilobyte. So it's a very short file that just contains the information we already typed in, the voltage here, and a git hash that tells us which version of the fitter ran this optimization, and there's a date, and here you have your parameters like electrical resistance and inductance. So you see it's not very big. Here's masses and F0, and that's all that's in this file. We will close this file without saving it. Inside this fitter, you can see the parameters here, and you can see that some of them are white, so they are only like purely TIL small parameters and not part of the advanced model. But we give you these TIL small parameters just to because it can help a lot of people understand what is it exactly. Because a lot of us, we have so many years with understanding TIL small parameters that it makes it a little easier for us. And then we have set 0, which is magnitude and phase, and we can see that we have the measurement data here in a dashed line and the model fit in a solid line, and yeah, it's pretty okay. And the same for the phase. There's a little bump here and here, and then you can see that things slip away here at the top end. But in the big picture, this is a good fit, and it gets an excellent rating. The algorithm used for this actually separates this impedance data, because you have 3 measurements into emotional impedance and electrical impedance, and you can see them here. Set M is the emotional impedance alone, extracted from your measurement data, and we have a range here of particular interest. You know, this area is marked And the same way we have the electrical data here, and this box is still marked here, and you can see that this electrical data is, remember, it's first we have the measurements, and then we extract the motional impedance, and then we go in and we take the measured impedance and subtract the motional impedance, and the remaining contribution is the electrical impedance. So it's quite derived, but it looks pretty good here. You get some noise at the bottom, and you have these resonances and whatnot coming up here. But in the big picture, this fit looks pretty good. Fits pretty well to what is the remainder of that measurement and processing of data. And then we have a model test, because indeed we did measure without added masses here in these colored graphs, and with 8 gram and 16 gram, and we can see that the model is pretty okay, matches up with the measurement here, also down the slopes of the sides, and that's why it gets an excellent rating. So we like this plot because it actually indicates quite clearly if there's something wrong with one of the measurements, which one is deviating. And from all this, with the 3 measurements, we can also not only subtract mechanical motional impedance, but we can also go one step further, and for each measurement point we can calculate a BL value. So you don't just get like a BL value from one measurement point, but you can actually derive a BL value for all measurements, and it's relevant to look within this boxed area. And here is the tab that gives you this BL derived curve, and just to make sure, BL doesn't behave like this versus frequency, but it's a processing of the measurement. And what we do is we average the BL value in this entire area, and that gives you a very accurate BL result. And then you can kind of see how it behaves outside this area. And the README tab that explains a little bit about it here with the graphs, everything I just talked about. So that's it. That's how to run and analyze the fit result. Thank you.